Welcome to Academy. This is the part 2 of the 3-part series on proving all the trigonometric identities from first principles. And this video is going to be on the cosine law. What is cosine law? Or in other words, the law of cosines. It gives you a formula for calculation of length of one of the sides in a triangle in terms of the length of other two sides. And in order to prove it, I have drawn a construction here. I have drawn x and y Cartesian coordinate axis, and I have drawn a triangle A, B and C. The lengths of the sides of the triangle are as follows. The side opposite to capital A is, the length is small a. Similarly, the side opposite to capital C is small c, and the side opposite to B is small b. Now, B is also the radial distance CA, that is the radial distance of A from the origin C, and the radial line CA forms an angle theta with respect to the x-axis. Next, I'm going to write out the coordinates of A, B and C in polar form. C is in the origin, so the coordinate is 0, 0. Remember the polar form equivalent of x and y. X equals r cos theta and y equals r sin theta, correct? And we are going to use the same to write down the coordinates of A and B. The coordinates of B are, the length is A, so the coordinates of B are A comma 0, correct? Because it is lying along the x-axis. You may be wondering, where is cos theta and sin theta here? Because the line CB is along the x-axis. So, the angle between the line CB and x-axis is 0. Therefore, the coordinates of B are A cos 0, which is nothing but A because cos 0 is 1, and A sin 0, and sin 0 is 0. So, the y coordinates is 0. That is why the coordinate of B is A comma 0 in polar form. Next, the coordinate of A in polar form. It is at a distance B from the origin. So, the R equivalent is B and the angle is theta. So, the coordinates of A are B cos theta and B sin theta. Next, I am going to use the distance formula. Okay, I am taking that A and B are known and I am going to calculate the length C in terms of A and B, and in the process prove the cosine law. Simple. I am going to use the distance formula to calculate the length AB, rather the length C. And I am going to use the coordinates of points A and B to do it. Now, what is distance formula? It's given here. D square equals x2 minus x1 square plus y2 minus y1 square. I am going to apply the same here. Now, AB square equals B cos theta minus A whole square, that is the x2 minus x1 equivalent. Plus, now the y2 minus y1 equivalent, that is B sin theta minus 0 the whole square. Now AB is C, so this will be C square, right? Let's expand using A minus B whole square, the binomial formula. This will be B square cos square theta plus A square minus 2AB cos theta, right? So this is B cos theta minus A the whole square. See this expression. Next, I'm here, no problem, this is 0. So this will be B square sin square theta. Now, we have this B square cos square theta and B square sin square theta. I can factor out B square and write it as B square multiplied by cos square theta plus sin square theta. And what is cos square theta plus sin square theta? It is 1. So I'll get just b square here, and I'll write out the final cosine law. So this is the law of cosine, that is the length c square is given by a square plus b square minus 2ab cos theta. Simple. Let me transfer this formula to our list and continue further. Okay, so we have the law of cosines. Is there a law of sines, you may be wondering? Yes, indeed, there is a law of sines. We have a triangle A, B and C. Let's call this as angle A, and this as angle B, and this as angle C. And law of sine says sine A divided by the length A equals the sine B divided by the opposite length B, and that is equal to sine C divided by the opposite length C. Simple. And I'm not going to discuss further about the law of sines because that's not required for our proof of trigonometric identities. But for completion's sake, I'm going to list out the law of sines also. Okay, so this completes our part 2 of the video. And in part 3, we will get into the derivations proper. Thanks for watching. So far, we have proved the complementary angle formula and the law of cosines using the distance formula and Pythagoras theorem. Next video, we get into the actual derivation of all the trigonometric identities. As always, it's been a pleasure. I would love to have you back again with Academy. Thank you.